Ever wondered why magnets stick to your fridge but not to plastic or wood? It's a question that might have crossed your mind at some point. This is the fascinating world of magnets and magnetic fields. Magnets, they're everywhere. From the small ones on your fridge holding up your shopping list to the enormous ones used in MRI machines in hospitals. And they all have something in common. They generate a magnetic field. This invisible force is what allows a magnet to interact with other magnets or certain types of metal. There are several types of magnets out there. Permanent magnets like the ones on your fridge keep their magnetic properties for a long time. Temporary magnets, on the other hand, only act like magnets when they are within a magnetic field. And then there are electromagnets, which only become magnetic when an electric current is applied. Each of these has its own unique uses, from holding notes on a board to powering the motors in electric cars. But did you know that our planet Earth is a giant magnet itself? That's right. You see, Earth generates its own magnetic field. It's this magnetic field that makes compasses point north and protects us from harmful solar radiation. The Earth's magnetic field is generated by the movement of molten iron within its outer core. This movement creates electric currents which in turn generate the magnetic field. To visualize this, imagine Earth as a giant bar magnet. If you could see the magnetic field, it would look like a series of invisible lines looping from the North Pole to the South Pole. This field extends far into space, creating a protective barrier around our planet. So, magnets are not just toys or tools, they're a fundamental part of our planet. This invisible force shapes our world in ways we might not even realize. From the smallest fridge magnet to the giant magnetic field of our planet, magnets and their mysterious forces continue to fascinate and mystify us. Think of magnets as invisible force fields, pulling in some things and repelling others. But how does this magical force manifest itself? Let's break it down to the basics. Magnets, my dear friends, are more than just fridge accessories. They are a fundamental part of our universe, governed by the laws of physics. Each magnet, whether it's the size of a pinhead or as large as a planet, has two poles, north and south. And here's where things get interesting. The north pole of a magnet attracts the south pole of another, and the south pole of a magnet attracts the north pole of another. It's like a cosmic dance, where opposite poles attract each other. But what happens when like poles meet? Well, they repel each other, refusing to be in close proximity. It's a bit like two strong personalities clashing, isn't it? Now, you might be thinking, wait, Earth has north and south poles too, right? And you'd be spot on. Our planet is a giant magnet, with magnetic poles that align closely with its geographical ones. This is why compasses work. The needle of a compass is a tiny magnet, and its north pole is drawn to align with Earth's magnetic south pole. It's a beautiful demonstration of the invisible forces at play around us every day. But why do magnets behave this way? The answer lies in the movement of electrons, the tiny particles that orbit around the nucleus of an atom. In certain materials like iron or nickel, these electrons spin in the same direction, creating a magnetic field. This field then exerts a force, attracting or repelling other magnets. So, next time you stick a magnet on your fridge or use a compass on a hiking trip, remember the cosmic dance of attraction and repulsion happening right under your nose. In essence, magnets are all about attraction and repulsion, much like social dynamics. Did you know that our Earth behaves like a gigantic magnet? That's right, our home planet is one massive spinning molten magnet. Let's dive a little deeper into this intriguing phenomenon. The Earth's magnetic field, also known as the geomagnetic field, is a vast, invisible force field extending thousands of miles into space. It protects our planet from harmful solar radiation, acting like a giant shield. But how is this colossal magnetic field generated? The secret lies deep beneath our feet, in the Earth's molten iron core. As the Earth spins on its axis, this molten iron churns and flows, creating electric currents. These currents generate a magnetic field that surrounds our planet, just like the magnetic field around a simple bar magnet. This giant magnet that we call Earth has a north and a south pole, similar to the poles on a bar magnet. But here's a fun fact. Earth's magnetic north pole is actually a magnetic south pole. That's why the north end of a compass needle, which is a tiny magnet itself, is attracted to the North Pole. The Earth's magnetic field is not just fascinating, it's essential for life as we know it. Without it, the solar wind, a stream of charged particles from the sun, would strip away our atmosphere, leaving our planet exposed to harmful solar radiation. This magnetic shield creates a safe environment for life to flourish, preventing our blue planet from becoming a barren, lifeless rock like Mars, which lost its magnetic field billions of years ago. Our Earth's magnetic field also plays a crucial role in navigation. Ever wondered how birds migrate thousands of miles, or how sea turtles find their way back to the beach where they were born? They use the Earth's magnetic field as a natural GPS system. So next time you marvel at the northern or southern lights, remember it's the Earth's magnetic field at work, protecting us and guiding life on Earth. Without Earth's magnetic field, life as we know it would be drastically different. Imagine if you could see the invisible lines of force around a magnet. This is the concept we're getting into now: magnetic field lines. Magnetic field lines are invisible lines that map out the magnetic field around a magnet. They are a powerful tool used by scientists to visualize and understand the complex nature of magnetic fields. Think of these lines as pathways that a freely moving north pole of a small magnet would follow if placed in the field. They show the direction of the magnetic force. Every magnet has two poles, a north and a south. Field lines always run from the north pole to the south pole outside the magnet, and from south to north inside the magnet. This forms a continuous loop, creating a pattern that resembles a series of concentric circles around the magnet. The strength of the magnetic field is represented by the density of these lines. The closer the lines, the stronger the magnetic field. Now, let's take a leap from the small scale to the grand scale. Our Earth, the gigantic magnet it is, also has magnetic field lines. The Earth's magnetic field lines emerge from near the south geographic pole and enter near the north geographic pole. They form a protective shield around our planet, deflecting harmful solar wind that could strip away our atmosphere. The Earth's magnetic field lines are not uniform. They're denser at the poles, where the magnetic field is stronger, and less dense at the equator, where the field is weaker. So, just like a magnet you might have on your fridge, the Earth has its own set of magnetic field lines, guiding compass needles across the globe and protecting us from solar wind. In a nutshell, magnetic field lines are not just theoretical constructs, they are a physical reality that influences our world, from the smallest magnet to the largest celestial bodies. Magnetic field lines then are like a roadmap for magnetic forces. So, we've learned that magnets and Earth's magnetic field are more than just fascinating phenomena. They are fundamental aspects of our world, unseen forces that shape our daily lives in ways we often don't even realize. First, let's take a brief walk down memory lane. We've discovered that magnets are not just those little things sticking your shopping list to the fridge. They are everywhere around us, from the Earth itself acting as a colossal magnet to the tiny ones in our electronic devices. Earth's magnetic field, an invisible force field surrounding our planet, is what makes compasses work and protects us from harmful solar radiation. It's the result of molten iron swirling around in the Earth's outer core, creating electric currents and thus a magnetic field. Now, let's not forget about magnetic field lines. These invisible lines form a pattern that shows how the magnetic force is distributed around a magnet. They emanate from the North Pole and curve around to the South Pole, creating a closed loop. But magnets and magnetic fields aren't just fascinating science concepts. They have very real, very practical applications in our everyday lives. Compass navigation, for instance, has been guiding explorers for centuries. The needle of a compass, itself a magnet, aligns with Earth's magnetic field, pointing towards the north, helping travelers find their way. Another significant application of magnetism is in the medical realm. Magnetic resonance imaging, or MRI, a revolutionary diagnostic tool, uses a strong magnetic field and radio waves to create detailed images of the body's internal structures. This non-invasive procedure has saved countless lives by detecting abnormalities early. From the compass in your hiking backpack to the MRI machine in your local hospital, the power of magnets and their mysterious magnetic fields permeate every corner of our lives. It's a testament to the profound ways in which the unseen forces of the universe make their mark on our world. From guiding explorers to diagnosing diseases, the the power of magnets is truly extraordinary.